Chandrayaan-3 mission, why ISRO wants to explore the Moon's south pole. If everything goes well, Chandrayaan-3 will be the world's first mission to soft land near the lunar south pole. All the previous spacecraft have landed a few degrees latitude north or south of the lunar equator. Set to be launched from Andhra Pradesh's Sriharikota on July 14 at 2:35 p.m., Chandrayaan-3 is India's third lunar mission. It is a follow-up to the 2019 Chandrayaan-2 mission, which partially failed after its lander and rover couldn't execute a soft landing on the Moon. According to ISRO officials, the Chandrayaan-3 will reach the lunar orbit almost a month after its launch, and its lander, Vikram, and rover, Pragyan, are likely to land on the Moon on August 23. Notably, the landing site of the latest mission is more or less the same as the Chandrayaan-2, near the south pole of the Moon at 70 degrees latitude. If everything goes well, the Chandrayaan-3 will become the world's first mission to soft land near the lunar south pole. All the previous spacecraft to have landed on the Moon have landed in the equatorial region, a few degrees latitude north or south of the lunar equator. The furthest that any spacecraft has gone from the equator was Surveyor 7, launched by NASA, which made a Moon landing way back on January 10, 1968. This spacecraft landed near 40 degrees south latitude. There is a very good reason why all the landings on the Moon so far have happened in the equatorial region. Even China's Chang'e 4, which became the first spacecraft to land on the far side of the Moon, the side that does not face the Earth, landed near the 45-degree latitude. It is easier and safer to land near the equator. The terrain and temperature are more hospitable and conducive for a long and sustained operation of instruments. The surface here is even and smooth, very steep slopes are almost absent, and there are fewer hills or craters. Sunlight is present in abundance, at least on the side facing the Earth, thus offering a regular supply of energy to solar-powered instruments. The polar regions of the Moon, however, are a very different and difficult terrain. Many parts lie in a completely dark region where sunlight never reaches, and temperatures can go below 230 degrees Celsius. Lack of sunlight and extremely low temperatures create difficulty in the operation of instruments. In addition, there are large craters all over the place, ranging from a few centimeters in size to those extending to several thousands of kilometers. Why don't some parts of the lunar polar regions receive any sunlight? Unlike the Earth, whose spin axis is tilted with respect to the plane of the Earth's solar orbit by 23.5 degrees, the Moon's axis tilts only 1.5 degrees. Because of this unique geometry, sunlight never shines on the floors of a number of craters near the lunar north and south poles. These areas are known as permanently shadowed regions, or PSRs. In a 2019 report, NASA said, "Water that happens to find its way into PSRs may remain there for long periods of time." Data from the Diviner instrument onboard LRO, Lunar Reconnaissance Orbiter, robotic spacecraft currently orbiting the Moon, which measures temperatures across the Moon, including PSRs, indicate that some surfaces are cold enough so that water is stable at the surface,